Students, now you see question number 2 says this. Show that any positive integer is of the form 6q plus 1, 6q plus 3, 6q plus 5, where q is some integer. It can be any number. We start now. As you know, Euclid's division algorithm says a is equal to bq plus r. A is the dividend, b is the divisor, q is the quotient, and r is the remainder. Here are where r is greater than 0 or equal to 0. That's the condition. Remainder will never be less than 0. It is always greater than 0 or it can be equal to 0. And this also be noted that it is less than b. Less than b. What is b? Yes, it is the divisor. Now, what are the possible numbers of r? Possible numbers. Possible numbers of r is equal to, as you know, we said it is equal to or greater than 0. So it can be 0, it can be 1, it can be 2, it can be 3, it can be 4, and it can be 5. Not beyond this, because as you know, the logarithm says it should be less than b. In this case, b is 6. Let us write down that also. b is 6. This you should know. In the question, it is written 6. Therefore, b is 6. And r can never be 6 or more than 6. It is less than 6. So, these are the possible numbers of r. 0, 1, 2, 3, 4, 5. Now, apply one by one and find out which is odd number. Example, a is equal to 6q plus r. So we take when r is equal to 0. We will take the first case. Applying r as 0, you get this equation. In this case, r is equal to, a is equal to 6q. And we know that in the table of 6, you always get even numbers. Example, 6 ones are, 6 twos are, 6 threes are, 6 fours are. Likewise, you get all even numbers. Now, plus 0 does not change the status of even or odd numbers. 6 remains 6. It is even number. When you add 0, 12 remains as 12, which is again even number. When you add 0 to 18, 18 is again even number. 24 is again even number. So, by adding 0, which is the first value of r, all these numbers will remain as even numbers. Let us write down this. In the next case where when the r value is 1, we take this as r value. Now apply a is equal to 6q plus 1. When you do this, imagine you put 6 plus 1, it becomes 7, which is odd number. When you add 12 plus 1, 13 is an odd number. When you add 1 to 18, becomes 19. That is again odd number. So whenever we add r, which is 1 here, to 6q, you get odd numbers. Please note that in the first case it is even. In the second case, when the value of r is taken as 1, you get only odd numbers here. A becomes odd number. So let us go for the third case when r is equal to 2. Yes. A is equal to 6q plus 2. Adding 2 to 6, you get 8, which is even number. When you add 2 to 12, that becomes 14, which is even number. When you add 2 to 18, it becomes 20, which is even number, likewise. So by adding 2, you get only even numbers. The A becomes even equation. Let us take when R is equal to 3. This is this case. A is equal to 6Q plus 3. It is very clear. By adding 3, you get 9, which is odd number. Adding 3, 15, you get odd number. 18 plus 3, 21 is odd number. 24 plus 3, 27 is odd number. So it's very obvious that you get odd numbers here. When we go for the fourth, taking odd value as fourth, when R is equal to 4, you can understand 6 plus 4 is 10, even number. 12 plus 4 is 16, even number. 18 plus 6, 24, even number. So you get all even numbers. Finally, when R is taken as 5, which is this, 6Q plus 5. 6 plus 5 is 11, you get odd number. 12 plus 5, 17, odd number. 18 plus 7, 25, odd numbers. So you get only odd numbers. You can find out this is one case where you get odd number. This is second case where you get odd number. The third case where you get odd numbers. So you can find out what you find here. Therefore, we find any odd integer is in the form of 6Q plus 1, that is this, 6Q plus 3, which is this, odd, or 6Q plus 5, which is this. We have given the answer.